Okay, good morning everyone. Uh, Glad to have you all back for this third lecture in the series. And if you can see the slide that's put up, what we will basically talk today is the topics we're going to cover is resource allocation and the basic leveling of resources. I've also included a summary of some of the alternate scheduling tools based on kind of interest that was generated in the first day. Where people asked, there are tools other tools which you would like to know about. So this is the more detailed outline. We'll summarize a little bit of the points we covered yesterday in lecture 2. We'll take up any discussion or questions you have on the two span bridge exercise, which I hope some of you got a chance to try to solve and try to at least understand the details better. We will go the main topic of today's lecture, resource allocation and leveling. When we will talk about basically how you allot resources based on the CPM schedule. We look at how the resources vary between early start, or the resource histogram varies between the early start and the late start. We'll talk about how over allocation issues and how it can be resolved. We'll talk about different resource situations. Okay, I cannot be comprehensive in this lecture, but we'll give a feel of different kinds of situations which a planning engineer might have to face, and then how they can be resolved. And then we'll kind of, even using money as a resource, it becomes very important to be able to manage the working capital on a project. We'll kind of touch upon several of these topics to give a feel of what they are. We will be not going into too much detail because resource allocation itself or resource management is a very specialized area on its own, but this will give you a feel of the complexity of the area. That would be the main focus. I will then go on to discuss some alternate planning tools. I mean, I won't call it scheduling, I'll call it planning tools. Some of them are scheduling, some of them are overall planning. We will talk about a little bit about location based management systems, 4D scheduling with CAD or building information models, design structure matrix, simulation. I will give a very broad brush, cover some of these tools. If you all want to do projects in these areas or look up these areas for further research, it'll be a starting point for the students. Okay, this is the objective of my covering the fourth topic. Now, just looking back what we did yesterday, if you all recall, we looked at the IS 15883 part 2, and we used this process which was defined in the standard as our basis for discussion. We talked about the work breakdown structure a bit, we talked about determining duration, we talked about dependency links, we focused a lot on time scheduling, okay, and the inputs and outputs that come from time scheduling, these being the inputs, and then we talked a lot about what are the outputs that come out of the time scheduling aspect, okay, and then we talked a little bit about how we can use the bar graph, how we use floats, how we use the various elements of the network analysis for practical kind of decision making. So that was kind of we got a feel, and then we actually went to the two span bridge problem, and I hope you had a chance to in some form of a real world problem be able to apply some of these concepts to it. Now in the last lecture I kind of also said that we would talk about what a planning engineer does, and I thought I would put these slides in the beginning of this session because I think it's very important that you understand what the role of a planning engineer is in a project. I have a lot of topics to cover today, and I didn't want to save this for the end because I was not sure if we would get to it. I think it's extremely important because the series of lectures you're having from us here at QEEE is only an introduction to this area. Remember, there's a lot of depth, there's a lot of responsibility as a planning engineer, there are a lot of tools, and those of you who are interested in this kind of work, there's a lot more done. But if you look at the planning engineer becomes really a very, very important coordinator for the whole project. In many ways, the project manager depends on the planning engineer for all the information regarding the project. So, you can see initial job plan, scheduling of materials, coordination of subcontractors. There's just a tremendous amount of tasks the planning engineer has to do, And traditionally the critical path method, or what we are learning, the techniques we are learning today, is what they use to be able to do this level of coordination, to get the information to be able. Okay, I am not going to read through each detail. I have given this more for your reference, but you can see that, you know, project execution team, subcontractors, planning engineer should have good communication skills. It's not adequate for him to or her to have just good analytical skills and get all of this information, because only through communication skills you can actually get good data and transmit your plan properly. So a planning engineer's function is very critical, and that is we see that happening in several projects today. The planning function is moving over from just an experienced planning engineer to a planning engineer who has appropriate training. We talked about several certifications also that are part of the standards for kind of acknowledging somebody has planned. Now, one more point which I wanted to cover in before we kind of start with the topic is, when we look at a schedule, there are several levels. Okay, so we talked a little bit about the project master schedule last time. I just wanted to give you a formal structure as to the different levels of scheduling, and then you can see level 2 schedules, okay, level 3 schedules, and you can see in level 3 is initially developed by critical path. So level 1, level 2 need not use a CPM. Somebody asked a question about a milestone schedule yesterday. So level 1, level 2 can be at master milestone level. They need not be at a critical path level, which is the level 3 schedule. After we get to level 3, we get to even more detailed schedules. Level 4 and level 5 are at the execution level. So these need not again be, these are what do you say, outputs of the critical path method, but you might find there's a lot of variability here. So it need not be a CPM based schedule, although some sites have seen try to use a CPM based schedule at level 4 and level 5, and that's quite challenging. So just understanding that we are actually targeting to CPM level 3, and it is, and a planning engineer has to understand all levels and what each level is appropriate for. So CPM does not become the default technique for all levels of schedules. As per global practices, it's targeted level. So this is another part which you need to kind of understand and, you know, pick up skills to be able to do it appropriate. So we were here yesterday. We talked about how relationships, durations. We talked on the early start, early finish. We talked of how we can calculate all of these, and I hope you have had time. Without practice, just listening to the lecture, you will not be able to do this. You have to have several practice problems. I think some of the problems which I kind of skimmed over due to lack of time, you should be able to practice it and be able to get these, convince yourself that you know how to derive these outputs given the particular inputs. That is as far as analysis. We will come to this problem which I had given yesterday. I will be actually, I would be happy to take up any questions you have to clarify this before we go on to resource. Okay. Is there any question which I can take from the colleges regarding this problem? Okay, like I said, it will be more of a discussion, because I have given a certain way in which this grid is constructed. It may be constructed in many different ways. It can have different activities, but if there are any clarifications from my side which I can give, which can help you kind of resolve any issues in the mind, I would be happy to do so. We will be taking this problem up again towards the end of the lecture, but at this stage, if there are any quick questions, I would like. Okay, if we will be coming back to this, like I said. So this was the duration and predecessor relationship I had given yesterday. I really encourage you to kind of do this by hand, solve it. Okay, I have got certain ambiguous durations and predecessors here. If you try to solve it, you can either make an assumption on it, or you can clarify with me what I mean by this. We will take this up if the clarification comes. But if I now move forward with this problem, if I take this duration and predecessor, these activities, durations and predecessors, and actually put it into activity on node diagram, this is the node diagram I get. So if we just go through it quickly, we are looking at the start activity here. Immediately following the start, we are saying we can do the piling, cast the piles or order the piles and start casting the beams. So that is activity 2. Now once the piles are available, I should be able to do all the piling work, right? That is 3, 6 and 9. 3, 6 and 9 can be started after the piles are available. Okay, so this is the constraint. Now after the pile is done in the east side, the pile cap can be constructed, and then Okay, the abutment will be constructed only after the pile cap, and so we will, so this now this structure has reached up to the abutment. If I go to the middle, I have the piling again, the pile cap and the pier, and when I go to 12, activity 12 is actually placing the girder. Okay, to place the girder here, obviously the girder has to be ready. After the girder is ready, both this pier and the abutment have to be in place for the girder to be placed. Okay, so you can see that for the girder to be placed, my predecessors are girder is ready, east abutment is constructed, and the pier is constructed. Only then the girder. So this is a physical predecessor relation. Similarly, for the west side, you have the pile cap, okay, the abutment, and even the girder here can be placed only after the girder is ready, the pier is ready, and the abutment. Okay, so once the girders are placed, you can actually start, laying the deck on each side, and finally laying the road. We are taking it as a single activity. So basically this AON diagram shows the sequence in which I am planning now to take the activity. Now there is a big assumption I'm making when I went with this sequence, and that is that I have unlimited. Okay, so what we are assuming here is once the piles are ready, the way I have sequenced these, it means that all three piling activities can start at the same time. Okay, if I go to a contractor and say, look, are you going to take 3 piling rigs and do all at the same time? He'll say that will not be economical for me, because it is just not efficient to have 3 piling rigs for such a small. So the relationship I have shown here is, while it's physically acceptable, because I have said unlimited resources, it might not be practically doable, because I would say no, I don't want to do, I want to first do 3, then do 6, then do 9, which means my resource relationships between these have not. Now it is, so unless I load resources to this plan, I will not really be able to get a proper duration. So here I have actually shown you the duration calculations. I get some duration, but duration is based on unlimited resources, which is not. Okay, so really we need to start understanding how to load resources and how to bring resource requirements into. So if we say now what is a resource? Okay, it's a broad term. I think all of us are familiar with this, materials, manpower, machine or money, all the M's which are resources, and I will still keep it at that. There are several more M's that have been proposed, but this is basic. We have consumable resources, we have reusable resources. Okay, so things like machine, we can keep using it. Materials, once we install it, it's done. Okay, so resource management becomes an extremely important part of scheduling or planning. Without resources, you will not there's not much you can actually do. There's nothing you can do, and if you don't manage the resources, you are not going to be able to manage. So we have seen how the duration of an activity, okay, is dependent on the resource. The more resources I could put on into an activity, the duration could be case to case based. But sometimes you might have, those who have done crashing knows that if I decrease the duration, my cost for each day might go up. But if my time is critical on my project, I can decrease the duration by increasing. Resources add to project cost. If I don't use my resources properly, I will be having a cost overrun. I might get the time in, the project in on time, but my cost will have a overrun. Okay, then it's not just the cost of a resource or the availability. We will see how the scheduling of a resource becomes extremely important to bring in the cost factor. Okay, and as we said, without all of this, we are going to face, without proper resource management, we are going to have cost. Now, when we talk of resources, what are the decisions we need to make? There are several. For example, if we are talking about material, we need to know when to order, when to order the cement or steel or brick or, glass. Obviously, if I am having a glass facade, I cannot order the glass, halfway through the project. I have to make sure that the glass activity is starting, and adequate time before that I have to order the glass. So you can now relate that if there is a glass facade activity, I should know the early start or when the activity is going to start to be able to make my order quantity. I need to know my storage requirement. How much of storage space do I need? If material is delivered to a site and there is no place to store, for example cement, it can get wasted, and that can cause a lot of problems. A lot of times, if a large construction company, if they know their resource requirements in a region, okay, not just a project, they can order resources for several projects and quantity discounts can be made. This saves the company a lot of money. So accurate resource forecasting on a project becomes very, very important. And when we talk about custom equipment, I will talk about this. Lead time is extremely important. Several of our common materials we could probably, if I give an order, within probably a week or two it can be delivered. For example, like cement or brick or sand might be possible. But there are other pieces of equipment we will talk about which are not that easy. I need to know when it is required and when it has. Same thing with manpower. Today we know what is my skill level, when are the skills required, when do I need welders on site, when do I need for example, you're talking about glass, when do I need the skilled workers to install glass on site? All of this is resource decision. Okay, we need machinery on site. There are special kinds of machinery which are required, and when should I mobilize? So this is a very big issue, especially in our country where we are not very equipment intensive. And for example, if you need a heavy crane, you'll have to plan for it months in advance. Otherwise, the crane will not be available when you. And if everything else is available and the crane is not available, you cannot. So all of these are critical. We talk about money as a resource, extremely critical. I think a lot of project profitability depends on how you manage the money, and money is based on how you spend it, is based on all the other resources which are kind of grouped in the project. So managing money in terms of cash flow, credits, profitability, taxes, all of these also kind of come into your resource management area or driven or influenced by how you manage risk. Now I have a figure here just to illustrate. For example, this is kind of a very heavy custom made equipment. Now to get an equipment like this fabricated and delivered, it might take anywhere from a year to 2 years. So once I place the order for this and it comes to site, I might not even have space. I should have space to store it. I should have the cranes to lift it and place it. If all this coordination doesn't take place properly, it's going to cost me. I'm going to waste a lot of money just having the equipment sitting around, or not installing it on time, or or loss. A lot of time will go on in several of them. Okay, now I think if I hope that has given you kind of a overview or an appreciation for why resources are important on a project and what are the decisions we make. So now let's go to when we take it back to a CPM based system, how do we actually start modeling start kind of incorporating resources into our project. So here we have our example from yesterday, very simple example. I use this example because we don't need to do too many calculations. I think you can see the forward pass, backward pass and the results easily. We did this also yesterday. So we have the results now expressed in a Gantt chart. So we had A, B, C, D. So we know that B has float, and if B is on the early start, it would start here. If it is on the late start, it would start. Okay, so you can see B is floating in this region as we discussed yesterday. Or B can float. Now let me go on to giving a very simple resource load. Okay, some of the numbers in the slides are not in the slide is not visible. So basically, to keep things simple, I've just put a single resource. Let's say one person is needed on each day. Okay, I need one person. It could be a very I'm not even trying to make this a practical example. It's a conceptual example. One person is required. So for each day the person is required, I've just put a 1, 1, 1, 1. Okay, all of you can see it. So A goes to 5. So this is basically 5 person days or man days, 4 person days or man days. So now once I take, so basically I have loaded the activity with a resource which is manpower based on the early start. Okay, so based on this resource loading, all I'm doing now is totaling at the column, at the row here, I'm just totaling the total resources at the end of the day. Very simple. So you can see here it's just 1, 1, all of this is 1. Where there's an overlap of activities, it has become 2, and then it goes back to 1. Okay, so this is my resources that I'm allocating to be able to do this. Now, and based on this, I'm now drawing a simple resource histogram. I've just translated these numbers into a histogram, and this is the histogram. I think all of you should be able to follow. Okay, so all we have taken is, so now on the first row here I have the same numbers, and then on the second row I have a cumulative which we can discuss later, but all this histogram shows is the number of resources required. So this is for a single resource, very simple project. This is what we have done to basically load resources onto my app. Obviously things get much more complicated than this, but if you are able to start out with this and understand how the histogram is generated, I think that is a very important first step. Okay, now I can take what do you say, how much flexibility do I have? So for example, if if I look at the histogram, I have one person required for 5 days, 2 people required, okay, for the next 4 days, and then back to 1 person. If for example here where there are 2 people required, somebody comes and tells me, oh, I cannot come on day 6 and day 7, you can give me any other days to come. Will I be able to handle it? That I'm somehow not able to mobilize 2 people on this day. Is there any way of me being able to handle that? Okay, so so what I can do is I can actually use the float of B. If I move B to this side, you can see that the histogram has shifted. The 2's have shifted from these 2 days to these days. So I've used the float of B to be able to change the shape of my resource load. Now, so you can see that because B has float, I'm able to use the float, but in doing so, something has happened. Okay, so what has happened now is B has also become critical, which I might not want, but it has given me some flexibility to be able to change my resource profile based on the float being available. Okay, now we go into the next problem. Now let me say on this project that there was no question of 2 people, there is only 1 person available, and that is it. I cannot allot more than 1 person to this set of activities. So I have said that, look, there is a resource constraint and only 1 person is available. Anytime you go more than 1 person, what you see in red is over allocation. Okay, so if I get a situation like this, what can we do? So from, you can see from the histogram, we can understand that resources allotted on 6, 7, 8 are more than available for early start. If I go to the late start, will it help me solve the problem? Okay, so I'm kind of throwing this open for a discussion, because from here then we will go on. We have basically done a basic resource allocation. We have got the histogram, we have done the early start, we have done the late start. We are now saying there is a resource constraint, there is only 1 resource that is going to be available to you and you are over allocated. Okay, can we solve this over allocation problem, and in this particular case, and what would we do? Can I throw this open as a question for discussion or any other clarifications that are required? Okay, so please post your questions or your suggestions on is there what is the only possible ways this could be resolved? Practical question, which can be, I think you don't need too much of CPM or background to be able to do. Okay, I have a question that says, any infrastructure project, how can we allot resources? I will come back to that. Okay, that's a broader level question, and it's an important issue. Certainly resource allocation, it's important. There are several resources. We will address that question, and if it's not addressed, please remind me. But yes, it's a very important question. But right now I would like a discussion on this topic. What is your, how can we solve this over allocation problem here? Is there any suggestions on that? Is there a solution at all? Is there a the 2 workers are not available to me, only 1 is available. Okay, so if I'm not able to, if no one's posting a suggestion in the next minute, I will continue. Okay, so we will yes, okay, I have a answer. The number of days will increase. Yeah, that's the only way to do it. Okay, so BATU has suggested, yes, to increase the number of days, because there is no other way, because you have over allocated the same quantity of work. So if I calculate the man days or the person days in this, you will find there is a total number of person days, and that quantity of work I will have to do, in which case I have to extend the duration. So that's one possible way. Another possible way is, might be this worker is right now working 8 hours a day. I say that no, I'm going to increase your shift, I'm going to pay you overtime, and when I pay you overtime, you're going to work additional work, do additional work. Instead of 8 or 9 hours, you're going to work 10 or 12 hours. Might be his productivity is less, but in doing that additional time, so instead of the 8 or 10 hours a day, I'm going to go to 12 or 14 hours a day. might not be what you say. Sometimes if it's urgent enough, it might be there. I'll certainly have to pay him more, but I could then finish it on the schedule, but basically I've increased the time of day. So there are different solutions like this which we can explore. I just wanted to kind of emphasize that in this particular case, I don't have much freedom other than to increase the number of work hours the worker is working or extend the project duration as it was suggested. Okay, good. Now if we take, I've taken a example 2 again, which we have solved earlier, and it is, I'm going to again illustrate with a slightly more complex example. We have solved this. We have to first, so we take a precedence relationship, do the network analysis, and we have the results of the network analysis. We have the critical activities, the non-critical activities. Highlighted in red are the critical, okay, and then we take and we do the same thing. I've gone to a single resource to keep things simple. I have loaded this network now with a this activity list with single resource on each day, and this is the histogram I get. Okay, I'm actually giving this more so that you can actually work it out later and see if the students can work it out and see if they get the same answer. Now obviously my flexibility is I can move from this histogram to this histogram because here I've moved everything to the late start. So this is the level of flexibility I have in changing the resource profile if I am within the floats of the activities which are obviously non-critical. So again, to kind of discuss, yesterday we talked about floats. Here I am mostly using the float of the full float of where it is, where to the maximum extent the activity can be moved. So you will find that some activities can be moved with free float, can be moved the extreme, the others will have to stop where they are free float and total float kind of stop. This is another discussion we can have later. Okay, now here I've shown, what I've shown is a cumulative graph. So this is the cumulative resources which I've calculated in the column here. Basically you're just cumulating this whole point. Okay, the whole daily load is just cumulated over, and if you accumulate here you will see finally you need 47, okay, person days or whatever to finish this, and this is the cumulative that is shown. So in the red you have the early start. If all activities on early start, this will be my resource loading. If all activities were in the late start, this will be my cumulative resource load. So you can see there's a bit of a variation, and these kind of graphs actually help the project team to understand what the resource loaded and other issues that come up with it. Okay, now we have right now taken a very simple project, a very a simply loaded resource. We have loaded it with 1 just to illustrate the concept. So we have a single project, single resource kind of a problem which we have taken up. We can have a single project, multiple resources, okay, which is makes things a bit more complicated. We can have multiple projects, single resource. So which is, so if you are talking about a single, so in any, a typical problem will be single project, multiple resources. Any project we take will have to we'll have certainly multiple resources which we will have to plan for and manage. But as companies get bigger, or there are region based companies, things like that, they cannot look at only a single project and manage resources only on that. They will typically have multiple projects in a region. And you have multiple projects, you can, yes, there might be very valuable resources which you have to then manage across your several projects in a region. For example, I mean, it could be a heavy crane like we talked about. The heavy crane cannot be allotted to a single project and just be idling in the project. It has to do its jobs on multiple projects, and allotting that resource to multiple projects become also a challenge. At the final level, we have multiple projects, multiple resources. So really speaking, in the real world, this is what most companies have to deal with. They cannot afford to deal with just single project, multiple resources. Although in concept, our academic concepts and things like that, we will start, or we will mostly cover single project, multiple resources. At a larger scale, you have to deal with multiple projects, So the person who asked me the question on infrastructure projects, for example, if you take the metro rail projects which are in a city, you will find that several companies, whether it's L&T or whether it's Gammon or whether it's Afcons, they have several projects they are associated with in a single metro. Okay, so they already have multiple projects within one large project, and they will have to coordinate multiple resources within. So a lot of it, the software or the, I mean, if you get to this level, you will find that there is, when we talked about the art and science, the science of scheduling is still there, but the art really becomes very important of being able to do this level of coordination. But certainly the theories we learn at this level have to be scaled up and can be applied. Okay, so I think this is so multi-project, multi-resource is also a very active research area. There are a lot of algorithms at all levels, okay, to be able to do this kind of resource scheduling. And the sophistication, so sometimes the complexity of the algorithm is not what matters, but like we discussed earlier, the data input, the data output, the data processing is not what matters, but the data input. And also very critically, the we talked about a planning engineer requiring communication skills. It is how the planning engineer understands the situation, understands what resources available where, whether he can make those phone calls, whether he can get meetings done, and be able to then arrange for those resources appropriate. Just I put this slide to give you a feel that this whole resource issue is really a very active research area still, and the complexity is huge. So we here talked about multiple projects in the same city, but I could have actually multiple projects across the region, which makes things even more interesting and complicated. Okay, now we are just scaling, so we are remaining with more conceptual problems as far as this lecture goes. But remember, as you get out into the real world and you scale these things up, there are different issues you will face. So we can now go on to a single project, 2 resources. So again, I'm just taking resource 1, resource 2. Same project as earlier. Okay, I have activities A to H. I have resources loaded, and here all I've said is there are, for example, we have 2 resources. Okay, we're taking equipment and manpower. So we need a piece of equipment and manpower. We say manpower is needed for the full. To keep things simple, what you said is manpower is needed for the duration of the activity, equipment is only needed for half the duration. So the resources are loaded appropriately, full duration and then half the duration, and you can then have your resource schedule. Okay, so you have for resource 1 and resource 2, you have the schedule as shown. So you can see the red bars, okay, are only going halfway because that's the equipment. The blue bars are showing the manpower is going for all through the activity. And based on this, I might be able to schedule that equipment and to ensure that it is available, or only if both are there, obviously the activity can be performed. So it's the responsibility of the planning team to kind of understand this ahead and be able to ensure that the resource is available for the activity to be done. Okay, now I can now take that resource and kind of say that, so here is making sure the resource is available. I'm now going into the cost on the money dimension and saying now I have to pay for these resources to be available. If I'm assuming that one resource is at 250 per day and the other resource is 500, now I can convert these into not just a resource histogram, but money. How much money do I need on each of these days? So how much money will be spent or will be required on my project on each of these days? Okay, so going into the money side, so I don't know whether this is clear, but when you get to the thing, so what we have basically done is multiplied the first part by the amount of money it takes per day, and the second, so this is by 250 and this is by 500, and I've again kept the numbers simple so that the concepts are clear and we don't get lost with the numbers. And all you're done here is then for resource 1, resource 2. Okay, I think okay, you can see the 3 graphs. So it shows the cumulative cash required for resource 1, okay, resource 2, and the total. So if as a project I have to also plan how my money will come in and money will go. This gives a feel of how I can manage my money, or this kind of an approach will give a feel of how I can manage my money as far as the project situation goes. We will go a little more deeper into this later. So I have a basic exercise here, okay, which shows, okay, so we will go through this. So this is, again, I'm going to reinforce some of the concepts which we discussed earlier. I have a basic exercise which I think you all should actually do. I'm not going to work it out here because I think we have several things to cover. but the basic exercise will be on is as shown. Okay, this is the network diagram. So we have given here the predecessor relationship. Okay, we have given the predecessor, the duration, and I have given trucks as a resource. Okay, I have given truck as a resource, and what we are doing is we are saying that only 10 trucks are available. So if I put this onto a network diagram and solve it, and then it's saying that there is only 10 trucks available for this project, not more. So I have the network diagram drawn here, okay, with the early start, early finish, late start, late finish shown. And my suggestion is, can you tell me, I mean, if any of you can kind of look at this, and ideally you should draw the bar chart, but might be take a few minutes. We can take about 5 minutes. Probably all the numbers are there. Draw the bar chart, load the resource. Okay, the resource loading is given here. Okay, I'm going to keep, I'm going to know resource loading is given here. Can you load the resource and tell me if there is an over allocation problem or not? Okay, this is given as an exercise. I would like you to draw the, I mean, probably first, I think this is clear enough for you to see. You can draw this network diagram, okay, and or you can draw the bar chart out of this, and then you can load the resource, and then let me know if there's any over allocation problem. If there is a problem, in which day or days do you need more than 10 trucks? So I'm giving this as an exercise. I'm kind of waiting for a few answers. You don't have the resource loading here. I will keep switching the slides. I would first like you to copy the network diagram, and or you can transfer this to a Gantt chart. Okay, you can do either copy the network diagram or transfer directly to a Gantt chart, and then I'll give you the resource level for each activity, which you can then load and tell me if the resources are up, there's a problem or not. Okay, we'll give you a minute to copy this to get the bar chart, or to go this before I go to the earlier slide which gives you the resource load. Okay, in about few more seconds I will go to the earlier slide which shows you the load for each activity, the number of trucks required for each activity. So now I'm going to go back. I hope you have got all these this data copied, and I'm going to go back to this. So you can now use the load. This is the load for each activity. Okay, so if I hope you have copied this list down, because then I'm now going back to the other slide, which you should be able to put both together and give me the, I mean, you should be able to calculate the number of, so we have 15 days for this activity. How many trucks are required on each day? So I would like you to put it something like that. If you have 1, 2, 3, all the way to 15, how many trucks are required on each day? I want you to calculate that. So obviously you have the bar chart which goes with A, B, C. You can either draw the bar chart, you can load the resources, do the cumulative, do the total for the day. I don't need you to do the cumulative. Do the total for the day, and you should be able to say for each day how many resources are required. Okay, that's what you need to fill out. Very similar to the charts which we showed. If there are any questions or clarifications, please post. If there are any clarifications required, please let me know. Otherwise, in about a minute, I'm going to kind of go ahead. It will be good if several of you have some solution and are able to discuss or clarify if there are. So this is what we kind of get. So you have 2, 2, 1. You can see the numbers here. Okay, and this is the set of numbers which you're getting. So basically we can see that I've taken the activities as it is. This is going 0 to 2, 2 to 5, 5 to 9. Just done the same thing here, 0 to 2, 2 to 5, okay, 5 to 9. Loaded the resources as specified in the table and just added up the columns. So 2 here, 1, 1, 6, 4, 4, 14, 14, 11, okay, and done this addition and basically got the total. So I wanted you to get this first. Now when you put the first row, we can see the histogram here, and you can see that if I have only 10 trucks available for 2 days, I require 14, okay, and this is not going to be possible. So I don't have the the resource. I don't have adequate resources because I'm only able to have 10. Now can anything be done? So the next question which I'm posting is, Do you have any solution for? Can you think of any solution, or what can we do? We had this discussion earlier. So what can we actually do? Should we delay the project in this particular case, like we discussed earlier, saying, oh no, I will only have I will not have 10 trucks here, so I can only, I will not have 14 trucks, so I'm 4 trucks short, so I delay the project. Should I delay the project, or what can I do? Think about it. Okay. So when we go back, we can see that in this project, these activities are on critical path. Okay, these activities are not on critical path, which means even if D starts on day 10 and finishes at day 14, it doesn't delay the project. Right now, on this in this graph, what we have is D is starting. D has 4 trucks required, and it is starting on the early. Okay, how would this resource histogram change if I move D to the late start? So D can start, remember, as late as 10 and go to 14, right? So instead of starting here, I move D all the way here, go to 10 and go to 14. What would happen to the resource histogram? Can you tell me? Okay, so I have so I have couple of answers. One says late start of D, that's correct. The other says resource leveling. Can you explain? This is what is resource leveling in a very basic sense. Okay, we are moving. So this is we had very peak level of 14 resources. It is over allocated. In one way, this is resource leveling. Okay, I will also explain other forms of resource leveling, not to great detail, but this is the most basic way. From a practice point of view, you want to kind of keep resource at a level in which which resources which are available in your resource pool. If I'm over allotted resource, over allocated, then I'm not going to be able to do the job. I'll have to delay or go into overtime or go into multiple shifts. All of these can be other problems. So I think all of you can see that if I actually move, so here I've seen the float of D has been moved, okay, to be able to change the profile. So the profile has changed from this to this, and in the current resource profile, 10 is the maximum, and they say that 10 is available to me, so this is fine. In some ways, I have kind of leveled or resolved the over allocation problem. This is not a proper resource leveling here. I have just resolved the over allocation problem. If I were to actually do a resource level, what I would do is try to say, no, here I have lots of dips and peaks and dips coming. My resource leveling would be to try to keep a uniform kind of resource over the whole period. That can be extremely. Ideally, I don't want to have peaks and dips. Either I want a flat resource level, or I want resources gradually increasing, a kind of a parabolic shape. That can also be kind of thought of, but you will find that algorithms required for that are fairly more sophisticated. We will touch upon that. We will not go into detail. So a proper resource leveling, there are several algorithms available. We won't go into detail, but I will discuss it in some form or the other. But other than moving D, are there any other options? Okay, think if there are any other options other than moving D. We can discuss that towards the end. Another issue, we have moved D now to the late start, right? We have moved it all the way to the late start. And in moving D all the way to the late start, we have made D also critical. Do we need to move D all the way to the late start? That is another question which we are asking, which we should just think about that. Okay, so there are 2-3 questions. One is, other than moving D, is there any other activity I can move? We'll discuss that later if there is an answer to it. But the immediate question is, do I need to move D all the way here, or is there any other option? The problem is, if I move the D all the way there, it becomes a critical activity. Now I am dealing with 2 critical paths, okay, which is again fair enough. Several projects have multiple critical paths. Or do I keep it, or is there any other option? Okay, and the other option is, I don't need to move D all the way here. I can move it up to here, and still I will have, okay, still I will land up with resolving this over allocation problem. So I still have 1 day of float on D. I can still keep it at that. Okay, so let's move on. Now we are actually moving to another kind of a concept of using cash as a resource. Like I said, cash is extremely money management is really very valuable on a project, and to be able to if you manage money on a project effectively, it means a lot. And this whole working capital management issue of a project is really finally in many ways that's what shows the profitability of your project. and a lot of that depends on how you manage your resource. So when we put money here, obviously money is money, but money goes to manage your resources, your materials, men, machinery, all of that is what is money is used for. So here is another kind of a problem which I am giving. So we have given again activity predecessor, we have duration, we have total value. Okay, what I have asked you to do is to plot the graphs for monthly and cumulative expenditure. We are familiar with this now. What decision making can you inform? So this is a discussion question which I cannot do it in this mode, but if there are any points which people want to take up, we can certainly do. Now I have given a constraint. Monthly expenditure is limited to, for some reason there is a constraint. I can get more than a lakh. Might be I'm borrowing money from the bank to be able to spend on this, or borrowing money from some source, and they say the limit is, overdraw limit is a lakh. In this resource situation, we are in this problem situation. This is the network we have. Okay, I'm not going to ask you to solve the network here, but please do it outside this lecture because it will give you more practice. So this is a network we have, and I'm making an assumption that the money is divided equally for during the period. So here we had the total cost of the activity, or the total money to be paid for the activity, assuming that it's divided equally. So so if you have 45 divided by 2 will be for each month. Okay, so that is the way we are assuming it. And so here we have the total value for the activity and the monthly value for the activity in the last. So this is the resource load which I have to now load on the schedule. So we have got the same process followed. We have a bar chart. I have the duration of, the duration of the activity shown in the bar, and each month the amount of money to be spent. I think all of you can follow, should be able to. The concept is the same, except instead of manpower or equipment, I've loaded it with the money equivalent. When you plot the histogram, now you find that there is this is your cash flow, or this is the cash required for each month. But if 100,000 is my limit, in some months I'm exceeding. So how do I resolve this problem? Again, we are going to the same concept that so here you can see where the floats are available. If you can see it, it's in clear. Okay, the critical activities are in red, and these I cannot move. I can again use my float. Okay, if I go to the late start, so this is my early start. If I go to the late start, again I still have a resolution. I have an over allocation. Simply by moving it all to the late start does not solve the problem. So what can I do? So here we have to see, can move. So obviously my float is available for me to move all across. Nothing is preventing me. Like we found in the earlier case, D need not move all the way across, right? It can stop at certain levels. So similarly here, I'm not moving all the way to the late start. I need not move. I'm moving activity C by 1, and activity D, as you can see here, is moved, okay, to the end of the 12th year, start here. And this has now my resource histogram, or my money histogram has, my cash flow each month has now in a level where it is below. So this is something I can manage. What have I done? Same project, same activities, same cost. I have just used my float effectively to be able to bring it within my resource limits, or what overdraft limits are available as far as. So these kind of decisions on planning become extremely important as far as project management is concerned, and as far as scheduling in the plan. So if we were at this level and the money is not available, and you have planned to start it here and you're not able to pay, you're not able to do things, a lot of complexity arises, which can be resolved by appropriate way of resolving the overall. Okay, so if so, this kind of histogram shows all three. We have in blue the early start, the late start, and the balance in green, the late start histogram in kind of red, and the balanced one. Okay, so let me kind of okay, I'll finish this problem and then take questions. The same can be shown as a cash flow diagram. Okay, this is the cash flow diagram for the early start. This is the cash flow diagram for the late start. And this is the cash flow for the balance start. And I put if I kind of superpose all three, I get so I have, by using the float on the project, I have actually changed the way the money flows through my project, and that becomes very, very important. So this is called the S curve. Okay, the way the cumulative money money flowing through a project is called the S curve. Plotting the S curve and managing the S curve becomes very, very important for us, because money as a resource tends to be very critical, and how you manage your money really, like we said, affects the profitability of the project. So how you manage generating this S curve and managing this S curve becomes very important for overall planning. And so with that, let me kind of take questions on any of the concepts that have been covered. Okay, is there any question any point of discussion? I think we have been talking for an hour. I think there should be, and we have covered several concepts. We have covered several examples. Any question, any clarification to be raised, please. Okay, there's a question on cumulative cash flow. First, let me take the question on cumulative cash flow. So basically what we are doing with cumulative cash flow is, okay, I'm going back to the slide here. So what we have got two rows here. One says total, one says cumulative. Total is basically the monthly total of each month. Cumulative, what I'm doing is adding. This is for month 1. This is month 1 plus month 2. Okay, month 1 plus month 2 plus month 3. So as we go down the months, we cumulate. So when we come here at 19, it is the total money spent over all periods are added up, and that's here. So you can see when you say, or you take month 10, it is total money spent up to month 10, which means adding up all of these values, adding up the total value from 1 to 10 is what is the value here. And this is the graph that's shown here. Okay, so I hope this cumulative cash flow issue question is resolved. It's important that you understand this, because it's used, it is extremely important as far as project management. Yeah, I have another question, using early start, or is it possible to have many solutions? Certainly the leveling part can have many solutions. Okay, so here what I have shown you, we said this was the early start. This is not an acceptable solution. Late start was not an acceptable solution. We said, we said this is an acceptable solution, but is there only one acceptable solution, or is this unique solution? No, there can be several parts here, several shifts of activity D or C which can provide an acceptable solution. So this is not a unique solution. So that's a good question. This is not a unique solution, and this is what makes the problem interesting. There might be other constraints. So if you have, this becomes kind of an optimization problem. Right now we are solving this based on our common sense, a bit of intuition, and a bit of visualization what the problem is. Can I mathematically model this as an optimization problem and solve it? The answer is yes. Will there be multiple solutions to this? Typically yes, multiple solutions. With this single resource, single over allocation problem, not too complicated. A good optimization technique can solve it. When you go to multiple resources, multiple projects, it is a different story, and we can kind of discuss that. It's more of a research issue still. Uses of cumulative cash flow. The whole okay, that's the question. What are the use of cumulative cash flow? The cumulative cash flow, managing money becomes the most important. Okay, so here we have shown just over allocation. So I'm going back here where I'm showing all three cash flow diagrams. So as a contractor, do I want to spend my money later or spend my money earlier? In many cases, I would like to spend my money later, because the money can earn, put it in a simplistic way, it can earn interest. So I would like to spend my money later, which means I would like to go on the late curve. But if I spend it too late, my project might be delayed. So the S curve is used to be able to find out what is the best way to balance. That is one. Two is, this is the S curve plan. We need to actually monitor our money spending. So when we go into monitoring and control, we have to plot the actual money spent. This is a planned money spent. We have to actually plot the actual money spent against this planned money. And that is how I get a feel if the project is, on target or not. So using this as my, whereas if I just use my bar chart, it will not give me the project progress plan. Okay, the cumulative will give me how am my project doing as compared to the overall plan of the project. So the S curve becomes not only an important planning tool, but more importantly as a monitoring tool to see where my project is with respect to where it is planned. Okay, so I hope that answers the question as the use of cumulative cash flow. I have another question. How do we calculate which solution is more effective? I assume this is regarding the many solutions. So like I said, there can be many solutions, and for a simple problem like this, all solutions might be equally effective, which is a multiple solution problem. But then you have to bring in and say, are there other constraints on project? For example, I mean, in this case, it's a cash flow problem, but the resource person who is kind of doing activity D might say, oh, I'm not available on certain days. In which case, the multiple solution doesn't really exist because of other constraints. So then we'll have to bring in other constraints and be able to find out which is a better solution. It can be subjective sometimes, but these are the challenges of optimization on large projects. Okay, there can be very subjective solutions. How do you mathematically model this can be quite a challenge. Can late start control cash flow? Will it affect overall project cost? So typically late start, yes, like we said, two problems with late start. Late start doesn't mean that my cash flow is fully controlled. So please don't assume that I'm suggesting everything should go to late start in order to control cash flow. All I'm trying to illustrate here is that float can be used to balance out the resources so that over allocation can be resolved. Float can be used to later on, even bring in on resource leveling. So in academic circles, I'm going to kind of talk a little bit about resource leveling. In academia, when we say resource leveling, in the ideal situation, we say we want a rectangular profile. That is, from start to end, we have a level. This was the classic definition of resource leveling. But then we also realize it cannot be fully flat as far as the resource goes, like manpower or equipment. We talked about the parabolic profile. How do you then bring in a parabolic profile? Some advanced tools have methods to be able to bring in these profiles through algorithms, but it might not result in practical solutions. So that's why I said it's still a bit of a research area, and the algorithms used are so sophisticated that actually, and a lot of research has been done, but how do you bring these to practice is still an open question. Okay, so coming back to this question of late start will control, I'm not saying we should do late start. I'm saying you should find a appropriate acceptable solution between your early start and late start. If the only acceptable solution happens to be late start, fair enough. But then you have to watch out that your those activities will also become critical. And if those activities become critical, then you're in, what do you say, your coordination has to be even better. You have to be aware of that. But then the critical path method schedule gives you a methodology to be aware of. Okay, so I hope I've answered the GHRC. Okay, so I have one more question. Which software can help in finding optimum solutions? So, I mean, if you go to tools like, for example, Primavera is probably the most sophisticated planning tool which we have in the commercial world, and sophisticated and popular, widely used planning tool. Primavera does have fairly good algorithms to do this kind of not only over allocation but also what we call leveling, okay, and leveling to the profiles which we would want to have. So again, I mean, like we discussed yesterday, the time we are putting here is absolute time. We are just using days and numbers, but calendar time also becomes important. Now, so in the real world, we have to put these days and numbers on a calendar. And if my peak work is going to occur during festival season, for example, in India, then obviously that's not acceptable. I have to then change my resource profiles or be able to move things around to match what my calendar tells me. So these kind of things are possible in tools like Primavera, but require in-depth knowledge. You cannot just use the function and expect the software to do the planning for you. You really need to know the limitations of the algorithms, how to use it effectively to be able to do this. And a part of the challenge of a planning engineer is not only to learn the concepts of planning properly, but also to be able to use these software tools effectively. So today it has become both. Now that is from a commercial side. Research side, again, there are several software available, which is very researchy. I would say, they are tools, they're part of MATLAB tools, things like that, cannot be scaled into probably a practical application. But from a research issue, there are several interesting simulations you can do with these. So I think, I hope that's answered which software. I think also if you actually go into the web and look, there are a lot of project management tools today, a lot of resource management tools today. I kind of said Primavera because that's what is widely used in construction, in the construction world. Microsoft project, all of you are aware, is also there, but it's, I think some of the features are not as powerful as Primavera. But there are a lot of niche software which offer a lot of specific niche applications, and resource leveling is also one of them. I'm not aware of the latest tools which focus only on resource management, but I'm sure there are, and if you search the web you should be able to find. Okay, any other questions on this, or let's move on. Okay, so we are now moving on to the next kind of characteristic of resources. I've just taken, this is more for illustration. I'm going to kind of leave it where I would want you all to kind of discuss in class how would this problem be solved. So here we are taking the same problem, but now we have two resources, trucks and workers. Okay, and we are now going to a single. So if you recall earlier, we are going to the single project, multiple resources. So earlier, up to now, we were talking about single project, almost single resource. Now we talk about multiple resources, same problem. All we have done is loaded two resources on the graph. So if you go back to my resource load, okay, we have loaded two. So I have resource 1 on the bar graph here, resource 2 on the graph here, and the total and the total for each month is shown here. Okay, and I've actually you can see this, and we have said there is a limit, right? If only 10 trucks and 15 workers are available, how can the over allocation problem be resolved? So you can see on these days there's an over allocation issue. Okay, if I move some things to the late, like move it along the float, there is a different balance. I'm kind of leaving this to you as an exercise. So please take this. You now remember in the earlier case we were working with a single resource, so we could move around and just talk about one graph. Here as we move things different, so remember I can't just move this. If I move this, all these 4s to the side, these 8s also will move to this. Okay, the 4 trucks if I move, the 8 workers will also move here, which means this might get overloaded with work. So I will actually make the spreadsheet of this. Actually it's a very simple spreadsheet. My recommendation is please put this into a spreadsheet and see if you can play around with the activities to find a resource load which will be balanced. Very simple exercise, gives you a kind of a ability to do it. I've also used, okay, so the question that was asked earlier was timely. I've also said that you could put this in scheduling software. I think something like just Microsoft project will be able to handle a problem of this simplicity. Okay, you will either say it is resource kind of over allocation cannot be resolved, or it will extend the project duration. Okay, or it will find a float to be able to allot it appropriately. Now sometimes if you are not able to over allocate where multiple resources are concerned, you have to actually, what do we say, you will have to give priority to resource and you will have to allot it appropriately in that way. So there are a lot of subjective elements which come to when we talk about multi-resource single project itself, which means when we go to multi-project, multi-resource, you have to give priority or which project is more important for me, where can I delay, might be there are two projects competing for a resource, and one project, even if I delay by a bit, it is acceptable. The other project is extremely critical. So I have to have these elements also modeled in my software, so that when I do the resource, resolve over allocation or do resource leveling, these kind of aspects are also. So sometimes it's not the algorithm that is important, but it is the inputs that go into the algorithm and how the inputs are handled. How the inputs are sought, are the inputs accurate? Same thing as we talk about basic CPM planning, right? If the inputs are not accurate, all your answers are not. So here the same issue. Okay. So when we talk about resolving resource allocation, we were kind of summarizing this. Okay, we can use floats. That's what we have done so far to shift activities, and we have been kind of using float, and I think would be the way it could be done. It should be done, but a lot of times you'll find that people can just, I don't have the resources to do this. I will increase, if I decrease resources in the activity, I will increase activity duration. I have only 10 trucks, so yeah, I'll have to take more. So increase activity duration by reducing resource loaded and then project duration will also, okay, or I can decrease certain activity durations by increasing or shifting activities. Certain activities which are overlap, I will try to decrease their duration by so here my resource load is less. I will shift this to some other place and try to totally decrease the duration of the activity by increasing resource load. So there are different options available. Okay, I might be able to split the act. A lot of software when they initially came out were not able to do splitting activities. But isn't splitting activities something that's possible? I can actually start an activity. I can start an activity, okay, stop it, and then so long as its predecessor is not this thing is not affected, or even an activity with float here, for example, I can start it, or start it here, stop, continue later. So splitting is something which happens in the real world, okay, but software is not able to model split activities until very recently. So these are the complexities of real world construction which cannot necessarily, could not be modeled. Even other than splitting, there are several other complexities which software alone cannot handle. You have to be able to do it from an implementation point of view, using the numbers from the software as a guide. Now overtime and shift work, we discussed this earlier. I can just increase the amount of time a worker is working, the effort is the same, but my duration may. Can I substitute resources if something is not available? If I don't have, I can't mobilize 10 workers for some kind of an excavation job, might be the workers are not available. Can I get some kind of an equipment which will, or if I have a demolition job and a piece of equipment which is available to me, replace something else which is not available, okay. Or finally, if you can't do anything, you have to increase the project duration, which means the resources will get will get distributed, durations will increase, and ultimately the project duration will increase, which is also something that happens. And in reality, that might be like in the first problem we discussed, or the first example we discussed, that might be what is possible. Other things are not possible. And on while we kind of look at, so now let's go back to this this example. You remember we kind of discussed this with no resource constraints, and we said that this was the diagram, or the activity on node diagram. So if I now include, and this is the answer we got, okay, we got an early finish for the project of about 118. If I now include resource constraints, so I'm saying I have a single gang for concreting, piling, girder lifting and road work. I'm taking resources as my crew, or I'm just using a gang. Gang is coming with the equipment and everything else. I just have a single gang for each. Now as opposed to here, where I could say that I could take up piling, all three piling works simultaneously is possible because I had unlimited resources. I'm coming back here and saying no, I have to finish the east side, then go to the middle, then go to the, this is now becoming a dependency. So this is a resource dependency. Similarly, with my concreting, I'm saying that my pile cap, I have to do 4, then do 7 and then do, okay, assuming that these two are finished. And similarly, you will find that the resource dependencies are also now being added, and based on resource dependencies, the project duration. Okay, so if I had modeled it without any resource dependencies, I didn't model resources and I just put durations on this, I will not have to model. Now the question comes, should I model resource dependencies this way, or should I load resources on a project and let the software take care of allotting resources and kind of ensuring that things are leveled based on resource availability. Actually, in several projects where we have seen CPMs developed, most people tend not to load resources because of the variability of resource availability on several. If you don't load resources onto a project, then you need, which means your CPM is already your CPM, your project, your CPM software, or what you're putting in the software is already compromised because you're not loaded. But if you actually load resources properly, you don't need to do this relationship because the software will take care of taking the resource constraint into account while doing the CPM calculation. And then when you increase resources, so for example, if I started out this, I had halfway through the third halfway through installing piles here, the contractor decides to mobilize one more piling rig. This becomes a problem because I'm constrained by saying one resource. It's built into the CPM. Okay, whereas if I had left it in the earlier case, my resource constraint is not explicitly in the CPM. If my software models it as a resource constraint, then as I change the number of resources, the whole duration will be adjusted based on resource availability. So we have effort driven, or duration driven. Okay, if you go into the tools, you will find this, and if we are going to make it effort driven, we have to do this appropriately based on the resources that are there. So for simple, I would say, projects where you're or even where projects where you're not loading your resources at all onto the tool, this approach might be okay. But really on most sophisticated approaches where resources are put into the tools, it is better to leave it open-ended and let the tool take care of the resource management, but you actually have to know what the tool is doing. So I have taken that same thing. I can have resource histograms. I think this is from MS project. I can have resource histograms drawn. I can have over allocation drawn. This is just to illustrate what the tool can do, and then I can resolve over allocation by the same techniques that we discussed earlier. Okay. So to summarize, we have kind of looked at to summarize the resource part. We have looked at the influence of resources on project cost and time, and how it matters, loading, over allocation, the S curve, the variations. The question on the S curve, it brings me back. Yes, the S curve is important in planning, very, very important in monitoring and control. Okay, so when you get in the monitoring, your earned value, all of it depends on the S. We talked about float and other techniques to resolve over allocation. We finally talked about resource constraints in precedence relationship, what we just discussed as far as the bridge problem is concerned. I put a question mark here because you have to be judicious in selecting if you want to put the constraint in your precedence relationship or not. Okay, if you put it, you're locking yourself to those resources in the project. If you don't put it and you don't load resources, then you're in a problem. So you have to balance it out and make your decision with the knowledge of what you're doing. Don't just follow a procedure without understanding. Okay. Yesterday I showed you one open source project management tool. So here is another tool which is open source project management. I'm recommending these more for academic usage. If you don't have access to commercial software as a part of your college licensed copy, you can use these open source tools to be able to at least practice the basic concepts, CPM analysis, moving to a bar chart, loading, almost all of the things which we have covered, the concepts we have covered today are available. Certainly when you go in for more advanced usage, commercial usage, I don't think there are too many commercial level open source software which can address it. As any final questions on this resource issue, because after this what I'm going to do is go into alternate methods of scheduling. So this is my for the next 20 odd minutes I will cover some alternate methods, but if I can take any other questions on this, I will do so. Okay, we are at 11:28 here. I'll give a minute or two. If any questions can be raised on resources, this will be the time to do it, because then we are going on to kind of a wrapping up the more alternate tools. I'm not necessarily calling it advanced tools, I'm calling it alternate. Which software is used, what are the limitations in application of resources? Okay, like we discussed, a lot of limitations. Okay, I don't think the software or the alone can be comprehensive in resource planning. The software can help you, it's a tool, it can help, but the competence of the planning engineer has to be high. Okay, so there are several, in my opinion, several limitations. Software is only an aid as far as the resource planning and management go. It gives you reports, it helps with communication, it helps with many things, but you cannot depend fully on the software. There's a lot more which you have to know, the experience you bring in, the expertise you bring in. Okay, it is extremely important. Which software is used for resource loading? We said again, there's not single software, there are several software, features are different, capabilities are different. By default, I have heard, from what we have seen and we have used and we have heard from industry, Primavera is generally the most popular and widely used package, and it has very good, I would say state of the art resource management features as far as software goes. Okay, research software is there which will probably have even more sophisticated algorithms, but they are not generally used for commercial purposes, but for research purposes I think there's a lot we can kind of play around. Okay, any other questions? Okay, let me move on to some of the alternate tools. I kind of included this in today's presentation to kind of show you that there are a lot of other ways of thinking about scheduling or planning. Okay, some of these methods are very, they are not too far different from what we have covered, whereas other methods basically look at critical path method and say, oh no, critical path method is not a very good method. We should totally radicalize the way things should be taught or different. And sometimes when you go to those methods, you find no, still there's a lot of similarity to critical path method. And I think they are more a lot of debate in the management circles, project management circles, which is better, which is not. Okay. Okay, so I have another question here. Does splitting an activity affect the quality of the activity in overall manner? I think case to case basis. In some cases, splitting an activity might not affect quality, it might improve the quality because there are some learning curve things which you do in the beginning and then you implement it better in the second split. So I think case to case basis, but I think what we have to understand is activity splitting is a part of practical construction work, and where relevant we should be able to model activity splitting. That is I think what we need to take away. So I'm covering the following. Okay, location based management. Okay, many of you might have heard of 4D scheduling. So you especially using building information modeling or CAD. Okay, a more advanced tool called the design structure matrix. Simulation, specifically discrete event simulation, is a very it's not a new tool. It's been used for several years. I will talk a little bit about that. Can't go too much into detail on any of it, but I will try to give kind of skim through certain things which might give students who are interested in research or in learning more about these tools kind of a little more information to explore. I think that is the objective here. Okay, so location based planning is something which is becoming popular. Kind of ironically, it used to be popular in the earlier years. It kind of lost popularity with CPM coming in, and basically what it does is the key word here is the location. Work location is also a resource. None of the CPM techniques which we use can use the location. Space as a resource is not modeled. In LBMS, space is also modeled as a resource. Okay, and it is very similar to the LSM technique, which I think might be covered in some of your syllabuses. Very similar, but today we have good software tools to also apply this location based planning. So if you take location based planning, so today, without software, a good foreman or a good planning team, I've got a construction drawing here, and they will actually say that if they'll take a bar chart and they will say, if this is my plan, I will actually go location wise. I will say on day 1 I will do this. I will transfer my plan to a location in the building. I will not just say quantity and time. I will say quantity, location and time, and so then it makes things. So before what do you say, formal LBMS is used, certainly location based planning is used in best practices, but people would do things like this, that this is the part I have to do on day 1, or this is the part I have to do on day 2. Okay, it would go like that. So it would be very almost hand drawn on the plan to communicate to the workers or the crew what needed to be done. With location based planning, you have a tool which gives you, so many of you, if you are familiar with the LSM, you know that this looks almost like a linear scheduling method approach, and it is derived from LSM. Okay, and you basically are now able to model not only the progress of an activity, but also the location at which. So what you have here is, where is the activity going to be performed, and this shows the time. So the progress of an activity is also monitored. So to keep things simple, I'm kind of bringing this. So if typically they find when you do CPM scheduling, the location is not taken into account. If location is not taken into account, you get a schedule like this, where people are distributed and there's a lot of clash in your schedule. With using an LBMS, you can actually streamline, okay, and make the schedule far more synchronous, where all the activities can be done in a synchronized way, and this is one of the real benefits of LBMS. Now, can LBMS be applied to projects where activities, like we say project, we remember we said something is unique. If the project does not contain repetitive activities, it's more difficult to apply LBMS, but it's still possible. But we'll find that today even a building project has a lot of repetitive activities. So we find that we should be able to make use of the repetitive nature of the project and be able to apply LBMS. So I'm moving over here. Okay, so if you look at CPM, the CPM emphasizes duration and critical path, whereas LBMS brings in location into account.
So that is the key difference. Giving you a small example of a case study we did using LBMS. So this was actually a underground, it was a 32-kilometer cabling job. So very ideal for application of LBMS because it's a linear kind of a job. We had to do something called a location breakdown structure for it, okay, which is similar to a work breakdown structure, but you have to break it down by location now and include this with the work breakdown structure. And this, when we approached the planning team and asked for their CPM schedule, it looked something like this. Okay, after using LBMS, and there were several errors in the CPM schedule as far as location clashes go. After using LBMS, we were able to streamline the process, and of course, being a linear project, this was more like now a production process than a project, because one activity after another happened in a very systematic. Okay, I'm kind of going through these tools in a quickish way. We can certainly take questions at the end. Now, many of you would have heard of 4D scheduling, okay, or 4D planning. You can do it with CAD or with building information models. Both are possible. And as you can see in the slide here, I have my bar chart. I have my traditional based bar chart here, and this is then integrated with a CAD model of CAD or a BIM model, where each element of the BIM model, I can't show an animation over this medium, but you can get onto Google and see what all, if you do 4D scheduling or 4D CAD, you'll see that there's a lot of good animations which show, you can actually show the sequence in which this is constructed. Okay, so I can approach this as adding 3 dimensions to my schedule or adding additional dimension to my CAD. So you have three dimension plus time. That is why they call it 4D. So here again we have done quite a bit of work with BIM and 4D schedules. I'm just showing you some of the sequences which we have created for, this is for a GFRG building which we have built on campus and which some of our groups are known for. So I can show the whole sequence as the sequence of construction progresses. I can simulate the sequence of how the building will be. So this is on 4D scheduling. A little bit on dependency structure matrix. Now we have talked about critical path method. Critical path method is certainly used for planning construction. But when we get into the design phase, how do we plan design? Design is also a very important part of the project, as we saw in the first lecture. One of the big differences between the design phase and the construction phase is that a lot of what dependency information in design is based on information. In construction, we know that dependency is based on physical and resource. Okay, in design it's based on one, yes, resource, two is information available. And while we are all aware that design is iterative, okay, we talk about iteration in design, and only through iteration design becomes improved. Whereas obviously we don't want construction to be iterative, right? Iteration in construction means rework, and we don't want construction. So when you try to apply CPM into the design phase, you will find that you cannot model iterations, you cannot model cross dependencies. So if I have, for example, you can see a network here, I have start finish. If I say activity B requires information or dependent, or I mean E is dependent on B, but B is also dependent on E, I cannot use a CPM to model. It immediately stops. I mean, you try this in any project software, it will say, it will say looped relationship, and it cannot do. Now the DSM is, but in a design project we need these loop relationships. So what the DSM has done is it's a technique which allows you. So the same network is represented in a matrix form. So you can see this is a matrix representation. If you look, you'll see all the dependencies represented here in the matrix too. When I have a loop dependency, it becomes on the upper part of the matrix. So I can now represent my information in a DSM and then do various operations like partitioning, tearing. Again, it's very powerful technique. Clustering, I'm kind of leaving it to you to refer if you are interested. And ultimately, one of the simple answers from a DSM is, what is my team formation, so that information exchange. Okay, I can also use a DSM to sequence activities. I can use a DSM to, ultimately the results from a DSM can be put back in a bar chart and said, how should the activity be sequenced, when should the activity start, when should the activity finish, so that optimum information exchange and feasibility of. I'm not getting into that detail here, but I've given you a reference, okay, dsmweb.org, which will give you a lot more information on what a DSM. Simulation is an old area, okay, it has been around since the 70s in construction itself.
it has not been so popularly used in industry until recent. Now you will find that there are several risk analysis tools coming up in industry, and discrete event simulation, or we call it Monte Carlo simulation, is beginning to be used by the better groups in industry today, or by the more advanced groups. But if you go back as a research area, it's extremely interesting, a good academic area to do research in. I've given you a reference to a recent paper, so which can give you a lot more information on simulation. But to put it very simply, I think this is not very clear. But what I have modeled here is our ABCD example. You remember we had an activity in the first lecture, a project A, I think B might be B, D, B, C, D, E. I model the same activity as a simulation network here, and again I can't show you animations and things, but basically it allows me to model uncertainty. It allows me to specify a distribution, not just a PERT distribution, but any distribution for the activity, and I actually simulate the project taking place. Kind of like 4D, but this is done in more in purely in the mathematical space and not in the CAD space, and I can then get my distributions for duration. So kind of what do you say, a more a different kind of PERT, but in a discrete event simulation mode. Each network is run thousands of times to get different results in each run, and then each run is the set of runs are put together to derive statistics. So that's what simulation. Again, encourage you to look at this publication, which will give you links to more publications. Critical chain project management become quite popular in many circles today. Okay, there is a book which caused all of this thinking on critical chain. It is by Goldratt, very popular management thinker. And one of the key aspects of critical chain is it addresses practical issues. Okay, so for example, when we say early start in critical path method, or early finish, or we talk about activities with float, what Goldratt says is, even though there is float, people tend to do things in the last. If people tend to do things in the last minute, your float will always be taken up. So there is no point in doing critical path method and talking about float. We have to manage these projects in a different way, which are people centered. Okay, where people are given different kinds of priorities, different kinds of metrics to be able to manage, and he focuses on resources. The other thing he says is resources are not taken into account appropriately. So he focuses on resources and then creating and managing buffers through resources, and through this the critical chain planning is done. There's a lot of literature out there. I think this book is more a concept book. There's a lot of literature, a lot of resources on the web as to how CCPM can be done, okay, and there is a lot of software tools also available, but application industry wide, still CPM is the most, I mean it's widely used. Every project has critical path method. Very few projects are using, but certainly people who benefit from CCPM are advocating its usage. Is the last concept, more than a tool, I would like to cover is what we call lean project delivery. We are also kind of the Indian industry has been very interested in this, in the construction industry, because it looks at what do you say, trying to control your project right from project definition to the final. We talked about phases of a project earlier. So what the lean delivery is, so in some ways I can say it's trying to make a project more like a process. If we remember, we discussed that a process is much more efficient than a project. So with lean project delivery, it's saying, can we kind of try to manage a project like a process? So it's a very paradigm shifting kind of thinking that's bringing about. When we talk about project management, we talk about uniqueness. With lean project delivery, they're saying, okay, let's try to, even the unique things, let's try to do it as a process. Now obviously there are challenges in applying what works in a production system like Toyota production system directly into a construction kind. There are a lot of promising results from adapting lean to construction, okay, and to keep it in a very basic way, a key concept in lean is what we say as eliminating waste. And if when we talk about waste, it is not just your material waste. There are several kinds of waste which you should identify and try to do. Again, I've given you a reference to the Lean Construction Institute, which contains a lot of information on lean project delivery.
if you ask me, it is a good concept in terms of a philosophy to be applied. Are you able to get immediate results from it? No, but I think as a research community or out of interest, out of management interest, I think people should read more about. So with this, I'm kind of ending the session. We have a few more minutes for questions and I would be happy to take. Okay, I have a question. Define BIM and how to use 4D in CAD. Okay, so I'm going back to define BIM is a good question. It's something which we can do. I don't have the appropriate slides for it right here, but but when you look at BIM, when you look at CAD, for example, CAD is more graphic modeling, and when we use the word BIM, it's parametric modeling. So so basically, when you look at the building here, if it is in a CAD form, all we are seeing are graphics. If it's in a BIM form, we are not only seeing graphics, but this window is represented in the computer as a window, not as a rectangle translucent object. And the window can have properties as heat transmission, light transmission. All of these properties also get represented. So that's what we mean by building information model at the very basic level. It is not just the graphics of the object, but also the properties of object which are represented. That's when we use the term building information modeling. It is one core level of it. There are several other dimensions of building information modeling which I'm not getting into here, but that's one part. So the other way of looking, when you use the word 4D, what we are saying is I'm then moving in. When we use 3D, we understand, we know what 2D CAD is, we know what 3D CAD is. When we say 4D in terms of CAD or in scheduling, we are saying now we are linking the 3D model to a schedule. We know what a schedule is because that's what we've been doing in this lectures. I'm linking a 3D model, so I can now see as my schedule progresses, I can see how the building is going to change. So that is what we mean by 4D. I hope I've answered that. Any other questions or clarification? Okay, so for several of these tools which I covered, I have kind of given you just a very sketchy introduction. I recommend that you can go to the web or go to the resources where I kind of pointed out to be able to get more in. Okay, and I must also say that I've actually put these tools because these are something which we kind of explore. There are several other tools, and there's more than just this. But these are what we tend to explore and which we feel are potential tools which are or concepts which are making a change in concept. Okay, I'll wait for a minute or so more for questions. Okay, critical chain project management. Okay, CCPM. Basically, to elaborate, there is a lot of detail in CCPM too, less like in CCPM, but I will just elaborate based on our discussion today. We talked about resource planning today. What CCPM kind of the assumption of, there are two big key assumptions in CCPM, the way I had put it. One is that that everything should be resource centric. So they look at managing a project from a resource perspective, not from the duration and predecessor perspective. So that is one key part of the CCPM. Getting into details, you have to calculate resource buffers, you have to calculate other buffers, and then keep track of the buffers to be able to manage a project, which is too detailed to get in here. But please understand that resource becomes very central as far as CCPM goes, and bottlenecks for resources have to be resolved. So this becomes a very key thing. Second issue is to look at commitments, how people react to different timelines, how people react to the early start or the early finish, or all of that. So CCPM makes an assumption that people will only give I think all of us can relate to that. That work will only get done in time to meet the deadline. Okay, so even if you give, so unless you manage the project based on these deadlines and give buffers to these deadlines, you will not be able to get your project in on time. So this is the basic concept. It then puts it into more of a mathematical formulation to be able to plan and monitor. Okay, so there might be more elaboration. Again, please refer. There's a lot of information on CCPM on the. Okay, if there are no more questions, I'm stopping the session here. Thank you very much. And if there are any broad questions, I think might be QEEE as a way you can send it to them, and they will probably send it to me for discussion later. Thank you.